Hi everyone, and welcome to today's video. We're going to dive into a topic that's small in size but huge in importance: atomic structure. In this video, we'll take a closer look at what an atom is, what it's made of, and how its different parts like protons, neutrons, and electrons all fit and work together. Understanding atoms helps us better understand the world at its most basic level. So, let's get started and explore the amazing structure of the atom. So, what are atoms made of, and how do they work? Atoms are the fundamental units that construct all matter, from the air we breathe to the devices we hold. These minuscule structures are the basic building blocks of the universe, defining the physical and chemical properties of every substance. Understanding how atoms are organized and how they interact provides the foundation for modern science. The internal makeup of atoms. Atoms are composed of three primary subatomic particles: protons, neutrons, and electrons. Protons and neutrons reside together in the dense, central region of the atom known as the nucleus. This compact nucleus contains more than 99.9% of the atom's total mass. Protons carry a single positive electrical charge, contributing to the overall positive charge of the nucleus. Neutrons are electrically neutral, meaning they possess no net electrical charge. Both protons and neutrons have approximately the same mass, which is defined as one atomic mass unit. The third type of particle, the electron, orbits the nucleus in a vast, cloud-like region of space. Electrons are significantly lighter than protons or neutrons, weighing less than 1/1000th of an atomic mass unit. Each electron carries a single negative electrical charge, which is equal in magnitude to the positive charge of a proton. In a neutral atom, the number of negatively charged electrons precisely balances the number of positively charged protons, resulting in an overall neutral charge. How atoms determine elements. An atom's identity is uniquely determined by the number of protons contained within its nucleus, a value known as the atomic number. This number is the sole defining characteristic that places an atom into a specific element on the periodic table. For example, any atom that contains 6 protons is carbon, while any atom with 8 protons is oxygen. The combined total of protons and neutrons in the nucleus is referred to as the mass number. While the number of protons is fixed for any given element, the number of neutrons can vary. Atoms of the same element that possess different numbers of neutrons are called isotopes. Isotopes of the same element exhibit virtually the same chemical properties because they have the same number of protons and electrons. However, they have different atomic masses due to the varying neutron count. For instance, carbon-12 has 6 neutrons, while the naturally occurring carbon-14 isotope has 8 neutrons, slightly altering the atomic mass but not the chemical identity. We will take a more in-depth look at isotopes in another video. Arrangement and stability. The structure of the atom is defined by the small, positively charged nucleus surrounded by electron shells, which represent distinct energy levels where electrons are found. Electrons fill these shells, starting with the lowest energy level closest to the nucleus. A complete octet, or 8 electrons in the outer shell, is a stable configuration. The outermost electron shell is significant because it contains the valence electrons. The number of valence electrons determines an atom's chemical reactivity and its tendency to form connections with other atoms. Atoms are most stable when their outermost electron shell is completely full, mimicking the configuration of noble gases. This drive for stability is explained by the octet rule, which states that atoms tend to interact to achieve 8 electrons in their valence shell. Hydrogen is a notable exception, as its first shell is full with just 2 electrons. This principle explains the motivation behind atoms either sharing, gaining, or losing electrons when they encounter other atoms. We will cover the topic of electron shells in a separate, more in-depth video. Thanks for watching. I hope this video helped you get a clearer understanding of atomic structure and how the basic parts of an atom fit together. If you enjoyed this lesson or learned something new, don't forget to like, subscribe, and hit the notification bell so you don't miss what's coming next. In our next video, we'll take a deeper look at electron shells, how electrons are arranged around the nucleus, and why that arrangement is so important for chemical reactions and bonding. Thanks again for watching.